Good everyone, welcome to GeoCitus, and today's topic is in structural geology, construction of a Mohr stress cycle. Okay, a short brief information. Now, when we have stress in geology, most of the structures, geologic structures that we have, that we study in geology, are formed by stress. The folds are formed by compressional stress, while the faults can be formed by the shear stress and also the tensional stress. Good. And this in the construction of more stress cycle, that type of stress that I want to find. The normal stress and the shear stress. Good. Now, what are the two steps that you need to know in the construction of a more stress cycle? A. You plot the greatest, the sigma 1 and the sigma 3. These are the normal stress. So the greatest stress, the greatest normal stress is sigma 1, and the least normal stress is what? Sigma 3. And they are to be plotted, normal stress are to be plotted along the what? X-axis. The shear stress, sigma S, are plotted along Y-axis. Some people call it torque. It looks like this, torque. Okay? Are plotted along Y-axis. The center of the circle should lie along the what? The X-axis. The second step, B. Determine the normal stress and shear stress value for a plane whose normal that makes an angle of theta with respect to the direction of the greatest principal stress. What does that mean? You can see. Now, it says determine the normal stress in direction of the what? The greatest principal stress, sigma 1. Now, the direction of the greatest, this is where sigma 1 is, this is where sigma 3 is. Sigma 1 is the greatest stress, while the least stress is sigma 3. Okay? So, the angle must be in the direction of what? Sigma 1. In layman, what I'm saying is, this is your x-axis. This is direction, this is where sigma 1 is. Your angle must be in this direction. If I say the direction should be in the least principal stress, it will be like this because this is where sigma what? 3 is. But that is not how we draw the Mohr cycle. The Mohr cycle must be sketched from the what? Direction of the what? Greatest principal stress. Good. Next, we're going to treat a question. We're going to treat a question. Using the Mohr stress diagram or equations of stress, determine the normal stress and shear stress value for a plane whose normal makes an angle of 30 degrees to the direction of greatest principal stress. Sigma 1 is 40 and sigma 3 is what? 20. And here we're given the angle, which is what? 30 degree. Good. First step. You have your graph book. Take your pencil. Now, you know what I said earlier? I said that what? The shear stress on the y-axis. The shear stress on the y-axis. And the normal stress is on the x-axis. Okay? You label it sigma s for the x-axis, sigma n. Good. Okay. So your next is to what? You must choose the same scale for both the y-axis and for the x-axis. The same scale. So we know that what is being given to us for the principal least stress, we're given 20, and for the greatest, sorry, sigma 1, principal 40, for the least sigma 3, which is 20. Now, what you need to do is to give yourself the scale. So, since this is 40, I can say that what? 2 centimeter represents what? 10 units. So, this is for what? Both the x-axis and for the what? Y-axis. You must use the same scale. Okay? You must use the same scale. 10 units. So, this is 0, the origin. So, here we have 10, 20, 30, 40. Here also we have 10, 20, 30, and 40, 50, 60, 70. And what did I say? Remember that I said that the sigma 1 and sigma 3, they are both what? Normal stresses. So normal stresses should what? Be on the x-axis, right? You know this sigma n, that's normal stress. So the location for sigma 1 is 40, sigma 3 is 20. So this sigma 1, which is 40, 40, sigma 3 is 20. Okay? Now, next, we want to draw our circle. The radius is what? Sigma 1 minus sigma 3 divided by what? 2. The radius of our Mohr circle is sigma 1 minus sigma 3 divided by 2. Sigma 1 is 40 in our question. Sigma 3 is 20. So the answer is what? 10. 20 divided by 2 is what? 10. Okay? So it's a very, very simple process. Okay? Yeah. So since you know that normal, this is the 10, like you can use your, this represents 10. Okay? You can just come here. Yeah. You've drawn your what? Your circle. Okay? We've drawn our circle. And for you to know that your radius is correct, it must cut across the what? Both the sigma 3 and the what? The sigma 1. Okay. So the next step is to what? Now, the question says the value for a plane whose normal makes an angle of what? 30 degree. Okay. Remember, in this, the normal, the B part says that what? The B says that what? The angle of theta with respect to the direction of the greatest principal strength, which means is this angle from here to here, from the x-axis to this line, it must be theta. So you come here, take your protractor, okay? When you put your protractor, then next, you have 30 degree, they measure 30 degree from the x-axis, from the direction of the what? Greatest principal stress, 30 degree. Okay, good. Then you join it to the center, from the edge to the center. Good. Correct. So now we've gotten your what? Your theta. Next, for you to get the shear stress and the normal stress, the shear stress, you will just what? You will a broken line from the y-axis to that point where that line touches the edge of the circle. Can you see? Any answer you get here is your what? Your sigma what? S. Then for you to get your sigma n, you do this. Any answer you get on the x-axis is your what? Your sigma n. Okay, good. We can get it. So for sigma s, we know that from here to here is 10 units, right? So each is moving by what? 1. Like 1, this is 0, 1, 2, 2, 3, 4, 5. So you can say what? Our shear stress is what? 5. While our normal stress, this is 30, right? This is 31. You know that to this place, that is 39. So our sigma n is what? 39. The PA. If you use the formula you will still get this. Okay, thank you. So this is the summary of everything. So let me just give a short recap on that. The first part is you must plot the greatest sigma 1 and sigma 3 within the xy coordinate system. Normal stress are plotted along x-axis. The shear stress are plotted along y-axis. The center of the circle lies along x-axis, as I've shown in the map. Okay, the graph. Determine the normal stress and shear stress for a plane whose normal that makes an angle of theta with respect to the direction of greatest principal stress, sigma 1. Okay, so following this and remembering the procedure, very easy. You'll get here. So this question is 4 marks and we are done. Thank you.